We've seen some simple examples of function objects such as the square functor and the addition functor here. You overload the function call operator, and in these examples I pass in some argument or you pass in some operands, right? Then the functor performs some operation. As I mentioned, the benefit of a functor over a function is that a functor can have a state. Now in this addition functor, as an example, I have two parameters for the left-hand operand and for the right-hand operand. Of course, you may want the parameters to be a reference to a const, if templated, or if it accepts user-defined types. Because as I mentioned in previous lectures, if you pass in an object with many member variables, then that operation can be expensive. So the same sort of stuff applies here. And also, if you're not going to make a change to the state of the functor, then of course you can have these overloaded function call operators be const, as you can see in these examples. So with that out of the way, I actually want to discuss built-in or predefined function objects in the functional header in this lecture. To use those predefined function objects, we have to go and include the functional file. And now we can go and remove our own custom ones. We have quite a number of predefined function objects, including function objects for addition, subtraction, and a few other things. So for example, these functors are templated, so I pass in int for the type. Addition is a functor, it's going to return int, so we pass in the left and right hand operands. And the same with subtraction, so we have these addition and subtraction. Addition is supposed to add 5 and 3, and subtraction is supposed to subtract 3 from 5. If I build around that, we get what we would expect. 5 plus 3 is 8, 5 minus 3 is 2. There are many function objects defined in the standard namespace, as you can see in the reference here on cppreference.com. Under utility /functional, I'll provide a link to this in the resources section. What we are looking for, I'll scroll down here. Yes, this section, function objects for common arithmetic and logical operations. Okay, you can see we have plus, minus, even for modulus and negation, and then you have comparison, equal to, not equal to, greater than, less than, even logical operations such as and, or, and not. If we go to the plus section here, from the documentation we can see this is a template, and then also you can see a simple possible implementation at the bottom here. It is going to return this. And as I mentioned, if you have your own sort of implementation for something similar to this, then you may want to do a reference to a t constant, so that you pass by reference to constant instead of passing by value. For a quick exercise, go and instantiate the greater and the less function objects and go and test that on the values 3 and 5. When we come back, we'll look at that in Visual Studio. Okay, I'm back, so let's go and create a function object for greater than. And for less than as well. We'll do greater than and less than. I'll build and run to test those. Less than is false, greater than is true, so of course you can also do the bool alpha right here. Build and run that again. Now we should get true for 5 is greater than 3 and false for 5 is less than 3. So with this, what I wanted to demonstrate is that we have a bunch of predefined function objects for arithmetic, comparison, and so on. These may suffice and may be all that you need for your program, and in that case, of course, you don't want to go and redefine those. Right, you want to use what exists already unless you want some definition that maybe has a state, as we've seen in previous examples.